Okay, so here's another question from Workplace 24.2. We're talking about multiple triangles within one single question. And this one, notice, does not have a diagram. Okay, so you have to draw a diagram here. And understanding the situation, reading it carefully, and drawing an appropriate diagram is going to be really, really important. So this one says an extension ladder. So that's a ladder that can be extended. You know, you might have one at home. It's used at an angle of elevation of 65 degrees. Okay, so envision this. We have a ladder that's propped up. Let's say it's propped up against a wall, but here is an angle of 65 degrees, let's say. Okay, might be a little short, but that's 65 degrees. So at its shortest length, okay, so if this is the ladder right here, let me just kind of complete this ladder. There's a drawing of a ladder. At its shortest length, it is 18 feet long. So that's 18. Okay, now notice we have a right triangle with 65 degrees. The hypotenuse is 18 feet long. Fully extended, this extension ladder has a length of 32 feet. So watch this. This ladder now is extended to, no, it's a bit long, but whatever, 32 feet. And so it's still at 65, notice. But now I have 32 feet long here, okay? And I'll just draw a little bit of the extension part of that ladder, okay? So you see now how we have two right triangles kind of embedded in, one is embedded in the other. They share a 65-degree angle. So in order to solve this problem, you should have an idea of what the situation is. So draw a diagram. Always draw a diagram. As well, if you draw a diagram on a test, and you happen to draw a slightly incorrect diagram, but you do all the work right, even though you have a slightly incorrect diagram, you won't get full marks, but if you do everything correctly, given the diagram that you drew, then you'll get most marks, right? So if you don't draw a diagram, you do things wrong, it's a little bit tougher to give you partial marks if I don't know why you're doing what you're doing. So draw a diagram, follow it through to the end, and like I say, even if you get the diagram incorrect slightly, I'll be able to give you partial marks for your work. Okay, so how much higher up the building will it reach when it's fully extended? So we need to know what this height is, and I guess I need to know what this height is up the building. I'll just label it X and Y. And then I need to find the difference between this height, right about here, and this height. So this is what I'm after right here. That's the question. See that? The difference. So I simply need to view this as two triangles, and to solve for both of these opposite sides to angle 65 and find the difference. Okay? So I tell you what, I'm going to give you a couple minutes, and I want you on your piece of paper, I want you to finish this question. 5A. Okay? 5A. That's what I'm looking for. 5A. So take 2 minutes and see if you can get this, and I'll show you the answer in a couple minutes. All right. So this first triangle, the black one, all right, we need to find out what X is. And so the relationship between an angle, the opposite side, and the hypotenuse, that is so, right? Opposite, hypotenuse, that's the sine. So sine of 65 equals X over 18. Okay? You have to write that equation. That's how you start. So you write that equation and you cross multiply, or multiply both sides by 18, and that gets rid of the 18 on the right side to leave X by itself. It's just easier sometimes to think of cross multiplying. So sine of 65 times 18 equals X, which is 16.3 feet. That's what this black X is here, okay? 16.3. All right, now that's basic from 4.1, so you guys got to know how to do that. This is base minimum, okay? Your trig functions here. All right. Now we can look at the larger triangle, which I'll write it down here again. The larger triangle is 65 here. It's a right triangle there. We need to solve for y, and this is 32. So that is sine of 65 equals opposite, y, divided by hypotenuse, 32. Multiply both sides by 32. That'll get you your y all by itself. Okay? Y is 29. The question says, and again, this is a multi-step question, right? If you stopped there, you're not going to get, you're not finished yet. So it says, how much higher up the building will it reach when the ladder is fully extended? Okay? So we've got this is the height at its shortest distance. This is the height in feet at its full extension. So the difference will be the subtraction of the two. There's your answer to the question. That's your answer to 5A. Okay? Remember, difference means a subtraction. Okay, so just looking at some of your work, some of you have a little more work to do than others. So you're going to have to go back and make sure that you are getting these questions correct. Check your answers, ask for help if you need it. But let's take a look at B now. Okay, so B says, how much farther from the house must the base be when it's fully extended? So we already have a diagram. This would be an example of where the house is right here, this vertical black line here. That's where the house is when it's at its shortest. So here's the distance away from the house. So let's put this as maybe distance 1. That's the short distance. Okay? Versus, compared to, when it's fully extended, is the full length here, distance 2. So we may need to redraw the diagram. Here's 18, here's 65. Now we have this as 16.3, so we need to find distance 1. And over here, we have 65, we have 29, we have 32, and we need to find distance 2. And then how much farther? So we need to find the difference between those two as well. Okay, take a moment, try and do this one here now. All right, so let's take a look at B. Again, we're trying to find the difference between the horizontal distances on the bottom. So there's two different ways you could do this, okay? So I drew the black, here we go. I drew the black triangle here, and you could use the trigonometry. You could do something like cos, which I did, which was adjacent here over hypotenuse. That's the ka, right? So ka, right? So you could set that up, and again, write the equation out first. Cosine of 65 equals adjacent over hypotenuse, d1 over 18. Multiply both sides by 18, and you get a d1 of 7.6 feet. Right? Now the other way you could do either of these, you could use Pythagoras as well, because we have a right triangle and we have 2 of the 3 sides. So that's what I did for the second one, just in case you wanted to see that. So this is 65 here, and but because we are just using Pythagoras' theorem, we just need to concern ourselves with the 3 sides. So d squared plus 29 squared equals 32 squared. This is the Pythagoras method. Solve for d2, which subtract 29 squared from both sides, take the square root of both sides, and you get d2 is 13.5. And of course, the question says, how much farther from the house must the base be when fully extended? So we're finding the difference between the two, which is 5.9 feet. Okay, so 4.2 is a little bit more complex, right, type of section. These are the first level of more complex problems here. So you have to have your trigonometry. You have to be able to use sine, cos, and tan in an equation to find missing sides and missing angles too. And then you can do more complicated problems like this. Okay, so that's question number 5 in 4.2.